Okay, aloha, welcome everybody. Thank you for being here to the first installment this academic year of our monthly Slice of PI-CASC monthly seminar. And this is hosted by the Pacific Islands Climate Adaptation Science Center, or PI-CASC. I'm Brad Romine. I'm the Deputy Director of PI-CASC on the university side of our University USGS Cooperative Center. The seminars are held on the first Tuesday of each month, so thanks for being here for our first Tuesday of the semester here at UH Manoa and online. Thank you to all the folks that are joining us here online. We welcome you folks to join us for lunch, future seminars here in the room, HIG building 210. We'll have lunch available for at least first 25 or so participants. So come over if you're here at UH Manoa or nearby campus. We also have pie today, as we often do. Rachel has kindly baked, so feel free to grab a slice of that at the end if you're here with us in the room. And it goes along with our Slice of PI-CASC theme. And today, Rachel's done a special one with a wetlands theme on it, so you have to check it out before we cut into it. Thank you, Rachel. This monthly Slice of PI-CASC seminar series is intended to provide a platform for sharing ongoing and state-of-the-art climate adaptation research and science and management applications in Hawaii, US affiliated Pacific Islands, and beyond. This presentation is being recorded. If you haven't caught that, it will be available on the PI-CASC website under our news and events section. So please feel free to go in there and check it out if you missed anything or want to recommend it to friends afterwards. For those joining us online, we ask you to please keep your microphones on mute during the presentation. We will have time for questions following the presentation, but do feel free to leave questions in the chat along the way, or you can certainly save them to the end as well. At the conclusion of our seminar, I believe we will have a short survey at the end that will pop up when you log off of Zoom. Will help us in with ideas to plan future seminars. So please fill that out before you leave us on Zoom at the end. And then with that, it is my pleasure to thank and introduce our two speakers today. Joining us remotely on Zoom today, we have Judith Drexler and Helen Raine, who will be sharing with us today about their work on prioritizing coastal wetland restoration on Molokaʻi Island in Hawaii. Dr. Judith Drexler, is a wetland ecologist at the U.S. Geological Survey California Water Science Center. Judy began her career as a postdoc at the USDA Forest Service in Honolulu, studying groundwater, surface water interactions in coastal wetland complexes. Since then, she's studied a range of wetlands in Hawaii, Micronesia, the southeastern US, the Pacific Northwest, and the San Francisco Estuary, California. Judy's research over the past 25 years has been focused on the impact of climate change, sea level rise, invasive aquatic plants, and hydrologic alterations on wetland sustainability. Judy's recent research is focused on melding Western science and indigenous knowledge in wetland restoration planning. We also have with us today Helen Raine, who is the Hawaii Conservation Coordinator for the Pacific Birds Habitat Joint Venture. She's been working conservation for 20 years and has carried out fieldwork in England, Malta, Peru, Zambia, and Hawaii, sometimes living for months in a tent. Helen received her master's degree in conservation from University College London and worked with Natural England to conserve coastal wetland protected areas in the UK. In Malta, she managed the Life, I'm probably not going to pronounce this name right, the Life Yelkawan Shearwater Project, which ultimately led to the designation of Malta's first marine protected area for birds. Helen is now based on Kauai, where she partners with state, federal, and nonprofit organizations to protect wetlands and native water birds. So with that, welcome to our speakers. Thank you very much for being here today. Pass it over to you. Yeah, go ahead and start the share when you're ready.
Hey, hello. Can everyone hear me? Yes? Okay, good. Thank you very much for having us be the first speaker of this year's PI-CASC seminar series. I'm excited to be here with Helen. Unfortunately, part of my screen is being blocked right now. Let me see if I can figure out how to get this thing off. Okay, well, I want to introduce my co-speakers, the people on the research team, Sally House, USGS, Jim Jacoby, a USGS retired, Pulamalima Kaipumakani, Butch Haas, Molokaʻi Land Trust, Arleon Dibin Young, Hawaiian Islands Conservation Collective, Nancy McPherson, Department of Hawaiian Homelands, and Brett Wolf, U.S. Fish and Wildlife Service. We really appreciate this opportunity to tell you about our work. This is one of my favorite projects, actually, because I not only got to work with a wonderful team of experts, but I also had the opportunity to meld Western science with traditional ecological knowledge. And this project has allowed me to learn much more about how Native Hawaiians think about the landscape. I just want to thank PI-CASC for funding our work and for having us here today. So these habitats, these coastal wetlands are important because many endangered species rely on them for their survival. And you can see here some amazingly looking damselflies, Pacific Hawaiian damselfly, the orange-black Hawaiian damselfly, and there's several types of snails, both marine and freshwater, that are really rely on these coastal wetlands for habitat. And many of them, we don't even know the status. And this one I looked up, but many of them are endangered. And now I'll let Helen tell you about the Hawaiian waterbirds.
Yeah, so a lot of the impetus for this project was our endangered waterbirds in Hawaii. If you take a look at that map, we all know we're far away in Hawaii, but I feel like that map really puts it in perspective. 2,400 miles from the mainland and a long way from the next archipelago. So we had these waterbirds that evolved with no mammalian predators, both in Molokaʻi and across the state. And that means that they're really vulnerable to predators today. And when you pile on the other threats like habitat change and a variety of other issues, we've ended up with these pretty low populations. So each bird there has got the population estimate from Paxton et al. 2022. And you can see they're pretty low. They're actually up. Some of these birds were down from, a handful of birds, 50 birds in the 1950s for the Alaiula. So they're improving, but there's still a lot of work to do. So the Hawaiian common gallinule up on the top left there, they've been extirpated from all of the islands except Kauai and Oahu. And this project on Molokaʻi was important as a potential catalyst to create another island, a third island for potential translocation or reintroduction rather. The Koloa maoli really only found on Kauai now. The other birds on other islands have hybridized with domestic mallards, so less than 1,000 birds there. And then Molokaʻi is particularly important for Alai keokeo, that's the Hawaiian coot with the white frontal shield, and the ayo, the Hawaiian stilt. You see a lot of those birds there. And we wanted to make sure that in the future, Molokaʻi is kind of supporting recovery and that we're not ending up with sites being a sink. And then Nene were reintroduced to Molokaʻi. They're not doing that well, although overall Nene are a fabulous conservation success story. Next slide. And then just to take a look at the kind of habitats these birds live in. So this is from some work that Erin Opie did at the Hea National Estuarine Research Reserve with Kawika Winter and Kako Oiwi. It just gives you an idea of the taro pond fields or loʻikalo, what they look like in the different stages. And it's easy to imagine how, waterbirds do well in that. They can move between the different stages for different parts of their life cycle. And when this Hawaiian indigenous agriculture was at its peak, there were over 20,000 acres and waterbirds were at their peak as well. There was enough habitat that they could move around as needed as different areas got harvested. And it was a great habitat for the birds and absolutely still is and could be even more so if we can nail down the right management and the right relationships with farmers. Next slide. And then there's lots of other habitats that the birds can live in, natural wetlands. So the main picture here is an ankyline pool, but the top picture there is a reconstructed wetland, the Makawahi Cave in Kauai. The middle one is the Alakoko fish pond. And the last one is Kaelia National Wildlife Refuge with these big shallow pools that are just perfect for water birds. So these are the kind of things that we're looking to restore on Molokaʻi, except the Ankalan pool. Next slide.
Coastal wetland habitat is also integral to the Native Hawaiian way of life. Helen just showed a loʻi. These taro patches are really the staple food for Native Hawaiians, and they had waterways within them so that you could also have silver perch, Hawaiian goby, Hawaiian mullet, and also grow the makaloa, the sedges, for weaving. But right now, if you take a look at coastal wetlands in Hawaii, they are highly degraded. Many of them are highly degraded from many things, from invasive species, and we're talking mainly plants, but also ungulates and other mammals. Water diversion, so these sites might be a lot drier due to that. Also, there's drought that affects these sites, sedimentation from the uplands, so you can have, impacts from, different land uses or different cropping systems in the uplands that end up having sediment go from the ridge all the way down to the reef. And not so much on Molokaʻi, but on other islands, you have a lot of development, a lot of land use change from that. So here you can see the mangroves on the upper left, the Rhizophora mangle. You can see the pickleweed, the Batis maritima. And you can see also in one of the sites, it was really a wastewater treatment plant, and right next to it, there used to be wetlands, but now it's a dump. And you can also see what the drought has done to some of these sites with severe desiccation. So they really are a lot of impacts to these wetlands, and restoration would really improve the habitat. Now I'm going to hand it back over to Helen. She's going to tell you about partnership building for this project.
So joint ventures work on partnership building. We're a habitat joint venture, and there are many of them across the USA. So this is always the first step for us, and we started in March 2020 with some of the founder members. And gradually the partnership grew from there, and you can see all the partners on the bottom there. We have Sustainable Molokaʻi, the Molokaʻi Land Trust, Kaipu Makani, and the Department of Hawaiian Homelands. They all have a presence on the islands. And then the Division of Forestry and Wildlife, Fish and Wildlife Service, obviously USGS with Judy. Those are the agencies that are also supporting all the work that's happening here. And we have the Hawaii Islands Conservation Collective on Molokaʻi too. And the PI-CASC project came about at a really pivotal moment for the partnership. I think we had the partnership, we were starting to think about what we needed to do, and it gave us the opportunity to do some really sound science work with the input from all the partners to look at what needed to happen across the island in wetlands. And it also gave us the opportunity to apply for grants, because the partnership was very much looked and was stronger with the PI-CASC connection. And the community outreach went hand in hand with all of that. So the partnership developed a vision, goals, and objectives document, and our community partners spent a lot of time talking to community members. And what they heard was that they want to revitalize traditional lo'i punawai, that's taro, spring-fed taro pond fields, and loko'ia, fish ponds, for sustainable self-sufficient food sources, which is great because those can also provide great water bird habitat and climate resiliency solutions. So that indigenous agriculture is really going to be the key to water bird recovery on Molokaʻi and climate resilience. Next slide. So this is just a glimpse of what our visions, goals, and objectives document looks like. And we also made a word bird just for fun. You can see the words that came out of that as important to the community and to our members. Next slide. So outreach took lots of different forms. Some of it was attending events like Earth Day as a partnership. Earth Day is really huge on Molokaʻi. They get, I think, between 1,000 and 2,000 people through the door. We also held individual community meetings, and then lots of one-on-one with our community partners. Next slide. And so the results of all that partnership building, underpinned by the PI-CASC project, was that it created a springboard for us to do some of the things that we wanted to make happen on the island. So the Molokaʻi Land Trust is now almost completed a wetland acquisition for Punalai Pond, which is one of the priority sites. Kaipumakani carried out a community restoration scoping project at the National Wildlife Refuge, and they had a Catalyst grant as well to look at connecting people with wetlands, and a grant from the Maui County Office of Economic Development to work on lo'i. And the other really helpful thing that came out of it was that it gave us the opportunity to pilot this methodology, this prioritization methodology on Molokaʻi, where it's a reasonably small island, so the data is manageable. Try it, tweak it, and we're now rolling it out statewide for the Pacific Birds Strategic Plan for Hawaii Wetlands. So that will give us some of the same answers, but on a statewide level of which wetlands we need to restore and focus our attention on. Next slide.
Okay, so we had a challenging task in front of us. How do you prioritize coastal wetlands for restoration without reference sites for comparison? If you look in the restoration literature, whether you're reducing impacts, you're rehabilitating a site, so not fully restoring it, but maybe enhancing it, or you're doing a full restoration, it always talks about finding this pristine reference site and then trying to do what you can to restore the site to that pristine condition. But in Hawaii, unfortunately, we don't know what those original wetlands look like. Starting with the Native Hawaiians, they were transformed. And then when European settlers came, they were extremely changed. The lowland, the coastal lowlands were very much converted to different land uses. And so what we have here is, a little bit of a conundrum. What do you do when you don't know what it used to look like? Well, what you can do is you can say, well, we want to have native species and we want to restore to wetland function, a good wetland function, so that it can provide habitat. And that's what we really focused on. And so we came up with our own approach, which is to develop a protocol for ranking the potential of coastal wetland sites for restoration. We had these 8 steps, and if you want a lot of detail on this, our paper just came out in the spring in Frontiers in Environmental Science with 12 supplementary tables of data. And then also we have a data release, a USGS data release. So these 8 steps, I'm going to be explaining them in the next slides, but just to give you an idea of what's coming, we gathered background information. We narrowed the sites down by legal entry and accessibility. We conducted rapid field assessments. We used NOAA data for sea level rise projections. We conducted the comprehensive bird habitat assessment. We engaged with the local, largely Native Hawaiian community to determine their preferences regarding restoration. And we set up and ran a GIS site suitability analysis to prioritize our sites. So now let's go through and I'll tell you a little more about how we did this. First, we gathered all the information we could on the sites, and this required creating a GIS database with pretty much the regular things you would think of for wetlands, soil types, vegetation, rainfall, streams, but also we had this wonderful groundwater spring database from all the way back from Stearns and McDonald in 1947 on Molokaʻi. We determined the boundaries of each wetland. Now, these weren't legal delineations, but this was just for this project. We used pictometry, high resolution aerial imagery, and Hawaiian state tax map parcels. And then because we had these wonderful collaborators, we asked our local partners about information on the sites. And so that really allowed us to learn as much as we could about the sites before we did any work in them. We narrowed sites down by legal entry and accessibility. I would have loved to go to the Oloku'i landslide, but that's a bit inaccessible. It looks like having some beautiful wetlands. Would be very interested to see them one day, but we probably would have needed a helicopter and a boat to get there. So we really tried to, choose the sites that we could get to easily and that would be more accessible for restoration. We had to get permissions, legal access from all of these places, and we had to do it 3 times because we got canceled twice because of COVID. So, but we were able to get all the permissions in line. And then we were able to conduct a rapid field assessment on our 12 coastal wetlands. And I just want to give you talk a little bit about these sites so you know where they are. The sites in yellow are going to be coming up again and again. So if you look at where it says Molokaʻi on the island and you go straight down, you can see Punalau Pound 1, Punalau Pond 1, Puna, and then Ohiopilo is right near it. If you keep going east, if you go to the north of the island, Kalaupapa Airport Wetland or CARE. If you go straight down from there, you can see Moku Pond or Moku. And then a little bit to the east of that is Kakahia National Wildlife Refuge. And then if you keep going east, you can see Kamahuehue Pond. And then you see a little bit more east, you see Kaupapaloi o Ka'amola, which I just call KOK because it's a mouthful. Okay, so those are the sites. And what we did in April of 2022 is we went out to these sites for a rapid field assessment, and we looked at the soils, we dug soil pits, we looked at the hydrology. Where are the sources of water for these sites? What's the depth of groundwater? What's the specific conductance or salinity? We looked at the vegetation. You know, how many native species are there? How many non-native species? What's the species richness of the sites? And also did bird counts. You can see on these imagery, 6 of the sites, you can see the soil pits are in orange, so you can tell kind of how we did this, how we laid them out. Okay, so I'm going to talk a little bit about the results now. And essentially, each of the things I'm going to be talking about is how we tried to understand and rate the sites, because we really needed to understand their status currently and what their potential was for restoration. So if you think about hydrology, you need a stable water source and you want moderate salinity range in order for a coastal wetland ecosystem to be able to thrive. So we were there during a drought, though. The drought had been going on for about 2 years. And so you can see in the top plot on the left, which is depth below ground surface, you can see that the depth to groundwater was about 36 centimeters. That's pretty low for a coastal wetland. And a few of the sites you can see were dry at 80 centimeters. But I've been studying wetlands for a long time, and they can actually have drawdown to a meter or even more during dry times of year and then rebound. So this didn't alarm me too much, but it does show the current status of the wetland. And then you can also see how dry it was by the salinity. Seawater salinity is 34, 35 practical salinity units, and you can see the desiccation in these sites with some over 100. And even, you know, you can see, but some of them are rather fresh, but some of them got very salty and actually had salt precipitating out on the ground surface. Now, what we did is we rated the sites on their hydrology. For example, this is the first submodel or bucket that we rated things on, and we went from 1 to 5, and I included for hydrology salinity, depth of groundwater, and then also Delwyn Oki had a wonderful groundwater flow model for the central part of Molokaʻi, and that gave us a coastal groundwater discharge. So I used all that information to come up with an overall hydrologic ranking, and that's what you can see here. Most of the sites are doing quite well. Poho'ele Pond is second from the right on the bottom there. It's not looking too good. It was very, very dry, but most of the sites had pretty good hydrology, and that was very encouraging. Now I'll talk about the soils. So for restoration, what you really need in a soil is good water holding capacity with good water availability for plants. So if it's all a clay, the plants are not going to be able to get the water out, and it's not going to be really good soil for colonization. So we looked at the percent organic soil carbon by weight. So if you want the biogeochemical cycling in the soils and you want them to have be able to hold the water, you need about 5% of organic matter, which is about 2.5% soil carbon. And you can see that that's very well, a lot of the sites definitely had a good amount of soil carbon. We had 2 sites that had organic soils, the rest were mineral soils. Ipuka Iole, the first one, is actually a floating mat of vegetation. Of course, it would have very high carbon content because it's not a soil. So what we did is we took this organic carbon in the soil, and then we also had the soils analyzed for soil texture, so clay, silt, or sand. what is a very good soil for wetland would be a silty clay loam or a silt loam. And you can see that almost all the sites have very good soils for restoration, and that's because these areas used to be wetlands. They're just very degraded, and soils take, you know, hundreds to thousands of years to form, and so the soils are still there. Sometimes some of them might need to be regraded. There's a lot of sediment on them, but they're still there. And again, we were very encouraged by this. Okay, so the vegetation part of the work was done by Jim Jacoby, and what he was really looking for is native plants to recolonize the restored sites, and looking at the ratio between native species and non-native species. And in most of the sites, that ratio was pretty close. There were some where there was a lot more non-native, but if you took all the sites together, there was no statistical difference between the native versus non-native species. And species richness, it didn't get tremendously high. I think we had 11 native plant species, but some of the sites stood out, such as the Kalaupapa Airport Wetland, the KOK site in Ohiopilo Pond had very nice species richness. So when I averaged the native to non-native species and the species richness, I got the overall vegetation rank. And really, they went all the way from 1 to 5. So you can see the sites, depending on how impacted they were by non-native species. And now I'll talk about the methodology for sea level rise projections. So I've done a lot of work looking at how sea level rise may impact wetland sustainability in the future. And for instance, in the Sacramento-San Joaquin Delta, which is the landward-most part of the San Francisco Bay, we have a lot of data that we draw from to be able to use this kind of cohort-based model where you take a parcel of soil and you follow it down through the years, and you need a lot of data on relative sea level rise, above ground productivity, sediment input, roots, compaction, decay. Unfortunately, for Hawaiian coastal wetlands, there are little to no data on above or below ground productivity of dominant wetland species, especially not native plant species. Vertical accretion rates, which is the deposition of organic and inorganic matter on the marsh surface, and that's how it can stay, keep its elevation in the tidal frame. We don't have decomposition rates of organic matter, compaction, shoot to root ratios for the native plants. Elevation ranges, in what elevation range do the native plants grow? We don't know, and we don't have localized estimates of sea level rise for the wetland areas, such as a gauge, a NOAA gauge, that would tell you exactly the sea level rise rates in recent years in these sites. So instead of modeling, again, we had to do it our own way. So what I did was I used the intermediate NOAA sea level rise projection for Molokaʻi for 2050 and 2100. And this is just sea level rise. We tried to use some other data, but they weren't available. That included wave-induced flooding, but hopefully that can be incorporated maybe in the future. We determined the current median elevation of wetland sites with a digital elevation model, and then we subtracted the projected sea level rise in 2050 and 2100 from the median elevation for sites, and then added back in a conservative estimate, but a good estimate, about 0.3 centimeters of vertical accretion per year, times the number of years to 2050 and 2100 for each projected wetland elevation. So essentially, we're really looking at their elevation capital. How much elevation are they going to have in out years? So here is what we found. Let's start with plot B. So elevation capital is really how high above mean sea level are the elevations of the wetlands. And so you can see for 2050, we've got pretty decent elevation capital. For 2100, probably from the data we have, probably most of the sites will drown. But the problem is this is a ballpark estimate. There's a lot of uncertainty, and this would be a very important area to constrain these estimates. It would be very important to do. Another thing that's really important when you think of sea level rise for coastal wetlands is migration space. And that is, can the wetlands move uphill a little bit if there is a gradient, which on Molokaʻi, it's pretty flat, but there is at least some migration space to go up maybe a little bit. And so you can see on a few of the sites, on 3 of the sites, we have a nice amount of migration space. But because Molokaʻi on the lowlands is very flat, and because we really need sustainable wetlands, we want to restore sustainable wetlands. I weighted the sea level rise projections twice the migration space ones, and that's how I did the sea level rise ranking. So over here, I incorporated migration, but then I did 2x for elevation in the tidal frame to get the overall sea level rise ranking. And as you can see, I mean, there's some that do slightly better than others, but you know, it's really, I think we need to have more information to really be able to tell what's going to happen, but we have at least a good idea of what's going to happen in 2050. And now I'll pass it over to Helen, who's going to be talking to you about the bird assessment as well as the local community preferences.
So for the birds, we used 3 methods to try and get a handle on whether the site was going to be suitable for water birds now and into the future. The first one was carried out at the same time as all of Judy's rapid assessment work, and it was a 10-minute point count using the state water bird count methodology. This was only ever going to be a snapshot. It was one bird survey on one particular day, and some of these sites are tidally influenced, which can affect when birds come and go. We did count T&E birds, but the drought conditions and the brevity of the survey meant that the assessment was not particularly representative. Next slide. So fortuitously, Arleo and Dibben Young has been assembling the most incredible data set for a very long time. She's actually gone back into the records of the Bishop Museum and any other places where she could find data, naturalists' notebooks, books, and she's created this long-term data set even from the 1800s. We used a subset from 2010 to 2020, where we considered the native and migratory birds and obviously the teeny water birds. And for the water birds, we looked at whether they were breeding, so it's either a no or a yes with a score attached to that, and the average count per site. And then to include the migrants, we looked at species richness, so the average number of birds per count. And not all of the sites had data, and I'll talk in a second about how we accounted for that. Next slide. So you can see at the top there the sites that did best for threatened and endangered birds, with the wastewater treatment plant coming out on top, and Ohia Pilo Pond, which is the Department of Hawaiian Homeland site, pretty close second. In terms of migrants, we have 48 different species, and you can see the top contenders there. And the top sites by average migrant count, you start to see some familiar sites there with Kamahui Hui, Kamehameha School site, scoring #1. Next slide. And then for observed species richness, so the sites that had the most number of species overall, Ohia Pilo again is up there at the top, but the wastewater treatment plant is still getting a look in at #5. Next slide. And so to try and narrow this down a little bit more, and also to think about not just which sites are supporting birds at the minute, but which sites could support birds in the future if they were restored and well managed. We carried out a habitat assessment. So we basically created a big matrix and collected as much data about the habitat value and the things we thought were important for birds from the range of data sources that you can see here. And probably the most important for that was the expert opinions of the people who actually manage these sites and own these sites and know them the best on Molokaʻi. Next slide. These are the criteria that we looked at. So, you know, some of them are obvious, such as the freshwater availability and the area. But we also looked at things like hazards. So if you restore this site for birds, are you still going to have problems because they're getting run over on unfenced roads, or they're hitting power lines as they come in, or it's next to a dump site? And we looked at things like predator control and botulism from the point of view of whether the landowners and managers felt that with the right support, we could create capacity to do predator control and botulism. Next slide. So we basically took all of that data, and some of it was narrative, but what we tried to do was create scores for the things that were the most important. And then we added those up together and weighted some of them. So for example, hazards was weighted 3 times because we didn't want to be restoring sites where birds were going to be at risk. And these are the sites that came out on top. So again, Ohiopilo, at the top there, Punalei Pond, which is the Molokaʻi Land Trust acquisition, and the Kakahiea National Wildlife Refuge is also in there in the top 5, with scores ranging from 55 at Pohoʻele to 105 at Ohiopilo. We did exclude a couple of sites, and I'll talk about that in the community section. And the great thing about this was we almost immediately could start using this bird habitat assessment to help us write grants to look at restoration. So we've just submitted an IFWIF grant to look at the top sites, the ones that were most important for birds and also climate resilient, to start the restoration planning work there. Next slide. And then the community part was perhaps the single most important part of this whole project. Our local community partners really spent a lot of time talking to the community. A lot of it was on one-on-one. They went and talked story. They chatted to people who had wetlands, people who had lo'i and loko'ia, activists, community leaders, talked to them about the project, got their opinions back. And then that was followed up by a larger community meeting when the whole PI-CASC team was on the island. And then following that, we tried to collate all that information with the Molokaʻi Wetland Partnership members to try and do a ranking on what the community preferences were. So we scored sites ranging from likely community opposition, like that one's never going to fly, to the community loves it and they would really like to see the site restored, like Kakahiea National Wildlife Refuge. And this one also received a weighting of 3 times the other components, except for sea level rise. And during this process, it came out that Paialoa Pond, which had been included initially, was a real sore point for the community. There was a long history of trauma and upset about the management of that site, and it threatened to derail the whole process. And so out of respect for those community views, we removed it from future consideration. And then Koheo was actually removed because it's being lost to climate change already, in the opinion of the manager, Olio and Dimanyang. Next slide. So community rankings, like I said, were high for Kakahiea and Kamahuihui, and also for the lo'i that belongs to or is managed by our project partner, Kaipumakani. That's actually already restored, but it could be expanded. So those were the ones that the community really wanted to see things happening. Paialoa was removed. And then the wastewater treatment plant scored poorly here, despite having high bird numbers, because I don't think any of us wanted a vision for a restored wetland to include the site where you have IO feeding 20 meters away from where the porta potties are being emptied. Or as Judy showed you, immediately adjacent, there's a dump ground. So that wasn't where we want the bar to be set, even though it currently does support perhaps the highest numbers on the island. And the community also talked about their concerns. They wanted to make sure that access was maintained for subsistence hunting and fishing. They wanted to ensure sites that had EV kupuna were respected, and the ongoing process, it was very important to keep involving the community and to have the restoration vision for each site planned with them, and that needed to include Lo'ikalo and Loko'ia. Next slide.
Okay, so now I'm going to tell you about how we took all the data that was collected and put it into a GIS site suitability analysis. So first I'll tell you what this does. It enables the analyst to qualify, compare, and rank candidates based on predefined criteria. So, and this approach has broad application. I was reading papers about finding the best location for a refugee camp, or finding the safest place for a toxic dump, choosing the best place to put a wind farm, and choosing the most productive area on Maui to grow coffee. So it has many applications. our goal was to determine the overall restoration potential of each site and thereby prioritize the best candidates for coastal wetland restoration. Now, there have been some other folks that use this approach, but we were the first ones really to include sea level rise and also to include community preferences. So in a nutshell, you take the data that's ranked from 1 worst to 5 best in the 6 submodels, which we've just explained to you: hydrology, soils, vegetation, bird habitats, sea level rise, and community support. And as we also mentioned, some submodel criteria were weighted higher than others to reflect their relative importance. And then we ran the model with 3 different scenarios. All submodels weighted equally, and this is where, so we started with that one, but then because community support is so important, not only for the restoration to take place at all, but for guaranteeing future management of the site, we weighted it 2 times and also 3 times, and same with resilience to sea level rise. That's just so important. If you want a site to be sustainable in the long term, that's got to be a very important criteria for this model. So we had the 3 different scenarios, and we ran the model. And here is what we found. That's why I mentioned those sites in yellow in the beginning, because they're our top contenders for restoration. It's really interesting that even with the different weighting schemes, it really didn't change a lot. The top 3 stayed the same. There was a slight change in, priorities 4, 5, and 6. But we were pretty, it made a lot of sense to us that these sites came to the top of the list, and we consider them our blueprint for coastal wetland restoration on Molokaʻi. And you can see the sites, the top ones, 1, 2, or 3 in green circles, and you can see the ones 4, 5, and 6 in the pink circles on this map of Molokaʻi. Okay, so that's our prioritization. But what else did we learn about Hawaiian coastal wetlands while we were out there and while we put together all this information? Well, one of the things I think I've already mentioned is there's really a paucity of knowledge of coastal wetland resilience in Hawaii. So, and this relates to especially vertical accretion rates and knowledge of the potential for wetland plants to be able to handle increased flooding. Also, groundwater springs are essential to coastal wetland sustainability, but there isn't an updated map of coastal springs. I showed you that Stearns and McDonald 1947 data before, and you can see this image of one at the wildlife refuge, and you can see the spring there, but actually there's a bunch of seeps along the north part of that site. But in the KOK site, even though it's the most amazing site in terms of groundwater discharge, I dug 2 soil pits on the southern part of it, right near the sea, and they were fresh. They were fresh water, but there's no spring shown here. So obviously there's some work to be done, some updating to be done. And also we learned that not all wetland types are known across Hawaii. And just by looking at 12 sites on Molokaʻi, we found 2 new wetland types. One is at the Kalaupapa Airport Wetland. It's a novel lithified bed wetland. And what this is, it's a depressional wetland. But everything that's growing that you can see here is only growing on 2 or 3 centimeters of soil. So it's really unbelievable. And it probably, the sand got lithified, which means it turns as hard as rock. Probably when they tried to restore this site to a fish pond about 100 years ago with the construction they were doing. It's unclear though how it really happened, but that's one of the sites that we saw that was different from anything else. And then in the site I was just showing you in the previous slide, the KOK site, I identified a coastal fen. Now, coastal fens are found in Indonesia. They're found in boreal regions and temporal regions, but I have not seen or read anything in the Western scientific literature about coastal fens in Hawaii. So I just got to thinking, what other wetland types are out there yet to be documented in the Hawaiian Islands? It was very interesting and intriguing. So, but I want to mention though that just because Western science didn't know about it, traditional ecological knowledge of the Native Hawaiians did know about these lo'ipunawai, or these spring-fed ponds. And if you read the Water of Kane, the last verse, which is in our paper, so hopefully you can take a look at that. The final verse actually describes both the sociocultural significance of coastal wetlands and their eco-hydrological function. it details the locations and the hydrologic connectivity of the waters of Kane. Now, Kane is the Hawaiian god of life and fresh water. And this chant or mele refers to coastal wetlands as locales where Kane is suspended above Kanaloa, who is the Hawaiian god of salt water. And this describes the relationship between the gods and how the freshwater lens floats above the denser saltwater lens in coastal aquifers, which if you study any kind of coastal hydrology, that makes perfect sense. And it also states that these locales, these coastal wetlands, are recognized for procuring life because, of course, that's where the kalo grows, and that's what the Native Hawaiians relied on for sustenance. So essentially this mele, this chant, showcases a Hawaiian socio-ecological system in which humans are perceived as part of nature. So a Hawaiian coastal fen, it may be new to Western science, but it certainly is captured in traditional ecological knowledge. Okay, and I know that we're running short on time, but I added some new classification of wetlands to the really nice classification by Erickson and Puttock from 2006. What I did was just really rounded out the hydrology, added groundwater and tidally driven or precipitation and groundwater driven. And then the sites can go from all the way fresh, even though they're at the coast, to brackish and even saline, of course. And then the different kinds of geomorphology, a coastal lowland or floodplain, coastal depression, and then the different types of soils end up having many different kinds of wetlands. And I have a strong feeling that this list will grow in the future. So let me give you our conclusions, and thank you so much for your attention today. Most sites have suitable hydrology and soils for restoration. 11 native wetland species were found at the sites. 4 sites could provide prime waterbird habitat after restoration. The sites are mostly resilient to 2050, but after that, resilience declines markedly. The local community supports restoration at many sites, but ongoing co-production is an essential component for success. We found 6 sites highly suitable for restoration. Restoration will involve removal of invasive species, regrading sites, unearthing springs, planting native species, and in some instances, fencing to protect the waterbirds. Co-production of Western science and traditional ecological knowledge, is key for advancing wetland science, and I would say many other types of science in Hawaii. Additional wetland types likely exist across the wetland islands. It would be really neat to take a further look at that. And research is really needed to update spring maps and better understand coastal wetland resilience across Hawaii. Our next steps will be putting online the GIS site suitability tool that I described to you, and it's going to be embedded in a GIS story map about the project. The Molokaʻi Wetland Partnership seeks to facilitate restoration at one or more of the sites. We want to continue exchanging information with the community and providing learning opportunities for local students and paid work for community members as part of the restoration process. We also would like to collaborate with others to identify additional sites by melding Western science and traditional ecological knowledge. And that's about it. We're very grateful for the help we got from many people, and we'd be happy to answer your questions. Thank you very much.
Great, thank you. Thank you, Helen. All right, we do have some time for questions. I'm not seeing any in the chat just yet. Oh, here comes one. Yeah. Why don't we start there? I see one from Stephen Miller here. And I'll go ahead and read it, but Stephen, I welcome you to go ahead and off mute if you want to do it yourself. But question is, how long will restoration take, and how has that affected site selection relative to sea level rise?
Well, I'll take a stab at it, and Helen, I'm sure you have something to say too. I mean, restoration takes many years. I mean, you have to do the studies before, you have to get the funding, you have to, you know, carry it out, and then obviously you're going to have to track it. So it's really a very, very long process. But I think what we did in this, I think our knowledge that we gained is plenty good enough to choose the best candidates for restoration. And that was our goal with this work.
Yeah, and I think we have to recognize that while in an ideal world, you would only restore the ones that are climate safe past 2100, sometimes those sites are the most difficult, and the ones that will support the waterbirds in the interim period are going to be the ones that we need to focus on. So it's kind of, it's like a stepwise approach. If we need to keep the birds going and recovering while we think about how to shift sites backwards.
Great, thank you.
So
see-
can I ask just a quick follow-up? This is Steve. Quick follow-up is, were the community aware of this time frame issue? If you're restoring a wetland that's going to be gone in 2050, was that something that the community was aware of in their selection process?
Yeah, I think the community were aware that climate change is happening. There's a lot of work being carried out by Sustainable Molokaʻi. And actually, there's some really interesting sites there, because Punalau, for example, is a buried fish pond. It's filled with sediment. And as climate change intensifies and as the sea level rises, potentially you might find that fish pond is kind of more connected to the ocean again. And you might want to look at how you could restore fish pond functionality. So the community were interested in sites that revitalized practices that used to be widespread and aren't anymore, and that provided sustainable food. And I think that's what they want to see happening. And we have to try and connect what they want to see to what we can do and what works for community resilience and water birds.
And there was also a strong overlap between community preferences and our top rated site, which was really nice. So I think the community is definitely behind this. And I think, there's definitely more to learn about the sustainability of these sites. I told you about some of the uncertainties in 2100, but 2050, we have a pretty good idea. So I think that's a great way to start. And that's kind of how we're using the data.
Great, thanks, Helen, Judy. I want to give our in-person audience a chance. If you have any questions in the room? Moment. Kevin, please.
I was able to visit Molokaʻi, and the amount of erosion was really striking. Do you think that it could ultimately be positive or negative for these wetlands?
I could not hear that. I'm sorry. I even have it way turned up.
Yeah.
I was able to visit Molokaʻi recently, and the amount of erosion was really striking. Do you think that that'll be a positive or negative for these wetlands in the long term?
Are you hearing? It sounds.
Can you repeat the question? Because I can't hear it.
No, it's okay. I don't know. Maybe it's that microphone. Is it on? Yeah.
Put it in the chat, maybe.
Yeah, I can go ahead and repeat the question. I think my microphone's working well. It's Kevin Facenda asked a question. The amount of erosion on the Molokaʻi, you were there recently, you said, is really remarkable. And this is, you mean the land-based erosion off the hillsides there. Sorry, the question then beyond that is that beneficial?
Positive or negative?
Do you see that as positive or negative to restoration potential for some of these wetlands?
Well, that's a really good question. When I looked at the state of the sedimentation and the erosion, I was pretty amazed and kind of, it blew me away. But number one, wetlands are traps for sediment. So that's going to help the ridge to reef system. And we really look at this as the first step in restoration of that whole continuum, because that has to happen for ultimately the whole system to work well again and to be restored. You can't just restore wetlands and then not restore what's above the wetlands. So we're looking at this, it's our vision that this is just the first step in the whole ridge to reef continuum, and that, in the wetlands, I think we'll do a remarkable job in trapping sediment. So it will help initially, but further restoration of that continuum is really what we need.
Great, thanks for that question, Kevin. And the answer, let's go back to our chat online. I saw one from Elliot Parsons. Elliot is asking, is there any concern about a potential increase in botulism with climate change?
Yeah, I think there is a lot of concern. I'm not a botulism expert, but I've heard that the increase in water temperature is a worry. And I think as we think about restoration anywhere, basically for water birds, we have to think about water flow, because that is really the key. Water flow and really good management, being able to control the water so you can drain the wetland if you need to. It's something we've been thinking about on Kauai, actually, because we're looking at creating flood attenuation ponds to protect community, and how you integrate water control structures into that so you don't end up attracting birds and creating a big botulism sink. So it's something that's on our minds, I think, as we try and do restoration.
Great, thanks. Sorry. Oh, yeah, I saw Nancy. Thanks for joining us today, Nancy. Did you have a question? Just noticed you went on camera there.
Oh, no, I just had to add my little 2 cents in there to what Judy and Helen were saying about how we're really, I mean, DHSL is because we have control of the ahupua'a for multiple ahupua'a along the South Molokaʻi coastline. We are really looking at it at an ahupua'a level. And so we're not just looking at, shoreline stabilization and restoration of wetlands, but we're also looking at Mauka. And so that relates to your comment about sedimentation, because the introduction of ungulates really did a number on Molokaʻi, and that's when all the fish ponds filled in the wetlands. Up to 8 feet of sediment came down by the turn of the century. So it's a big job, but we really think that it's important work. So we really love being a part of this partnership and are amazed by the wonderful work that Helen and Judy have done, that we all did together. So
Yeah, we have some other partners on if anybody else wants to
Yep.
chime in. I know Brett's here from Fish and
Yep.
Wildlife and Birch from the Land Trust.
All right, thank you. I see a couple more. I see a hand raised in the online audience, a couple more in the chat, but we only have time for maybe 1 or 2 more questions. I wanted to give our in-person audience one more opportunity for questions here in the room. Okay, let's go back to the online ones. I see Sybil Lopez as a hand up. Sybil, you want to go ahead?
Mahalo, my name is Sybil Lopez. I'm speaking on behalf of myself. I'm born and raised from Molokaʻi. I do wear many hats in our community. First and foremost, representing the homesteads. We have 13 homesteads on the island of Molokaʻi. Just like what Nancy, we've been working with Nancy with her mitigation plan for our homestead areas. I know this only speaks to 1 out of the 12 homestead associations, but when you speak of an island such as this, 7,500 people on this island, and we're a rural country lifestyle. So when you talk about co-producing and the community, it's really defining the community that you're looking at. And sometimes, science overcomes intellectual properties with indigenous knowledge and generational knowledge. And I think just to get any word out, the key is that the indigenous knowledge and generational knowledge should be first and foremost. Like they said, they've been 1,000 or 2,000 people at the event of the Earth Day. But have you been specifically working with the communities that are from that area within that ahupua'a has generational knowledge? And you are only having a taste of Western science, what they could provide to you. But we have generations of knowledge, which we call our own intellectual properties, that is tied to this aina, that my children, my kukuna, which is my grandparents, that have taught us, and that we as our stewards are responsible to teach it, to the next generation. And that's the whole idea that I want you guys to keep in mind when you go to places like Molokaʻi, because it's such a special place to the people. And so no matter how much people come in and out with a short-term expectancy or a short-term goal, we always going to be here. Yeah, we, the people, always going to be here. So when you talk about co-production, it should be first and foremost the people, because once you leave with your data and the data sets that you would create, we still going to be here to pick up those pieces to decide whether or not we're going to be stormed your way or our way. That is what you have to think of, because we subsist on our side. When you talk about Makai and Ahapua'a, me and my kids fish, me and my kids hunt, me and my kids gather, because that was the kupuna way that was taught. So when we have to, in these Western society, these colonization times, when you have to depend 95% of your imported goods to support one family home, Molokaʻi is one that subsists on their island. And that's what you got to understand, because even though you took looking at a microscope, one, just looking at a micro view of how wetlands perform in that specific area, you have to understand how we look at it in the whole entirety. I did attend one of those meetings when they were on Molokaʻi, and that's the same question that I asked in person, and that's the same thing that I'm going to continue to ask until you guys have to modify. People come with the land and the water, and science only going to be there for a short time, but we've been in there for generational. Oh, that's all I have to say, Mahalo.
Thank you, Sybil. Appreciate that. Helen, Judy, anything you want to say in response or to conclude? Otherwise, I think we should probably stop there, running out of time here. Unfortunately, I do see a number of other questions there. I'll pause for a moment. If there's anything you want to say.
I think I just want to say it's been a great privilege to work on this project and to work with the people on Molokaʻi, and everything that we have done for the people to improve their environment. And we will continue to try to do that. And we're happy to work with anyone and explain. But really, this project is very close to my heart because I believe that using science together with traditional knowledge is a really great way to solve environmental problems. And so it's been a great privilege for me to learn as much as I can, and I will continue to learn as much as I can and listen to everyone. And hopefully we can restore some of these wetlands for the benefit of people and species on Molokaʻi.
Okay. Well, thank you for that, Judy. We're gonna have to wrap it up. I have a few things I want to say before we conclude here.
Hey,
Please
Brad.
join. Yeah. Oh, Helen. Sorry.
Sorry, I'm really sorry to interrupt, but I did notice that we have someone from Senator Hirono's office who sent in a chat, and I just wanted to acknowledge that, or maybe you're going to say we can work to respond.
We will
But anyway,
send-
thank you. Yeah.
I've saved the chat and I'll send all the remaining questions to Helen and Judith so that they can respond to them.
And can we leave the Zoom open for a little bit longer if they wanted to type back in a response to those? Yeah.
Sure.
Yeah. Okay. Okay. Well, with that, invite you all to come to our next PI-CASC seminar, which will be Tuesday, October 3rd at noon, with Dr. Rob Tonin and Paolo Mara Biggs, who will be sharing their work on reef ecosystem in Hawaii and the Pacific Islands, including an assessment of giant clam stalks in American Samoa. Please do take a moment to fill out the online survey as you log off, and look out for reminders and links to talks throughout the year, or visit the PI-CASC website at any time under events for more information or sign up links on that website. So with that, I'd like to give thanks one more time to our presenters, Judy and Helen. Round of applause for them. Thank you very much for your time. And thank you all to our in-person and online audience. We look forward to seeing you all next month. Mahalo.